Good morning. Welcome to today's video notes. And today our lesson is on the law of sines. Now to start off, I'm wondering who remembers how to find the area of a triangle. Do you remember this formula? Area of a rectangle was length times width or base times height. What is the formula for area of a triangle? Did you say 1/2 times base times height? Or maybe you said base times height divided by 2? Nice job. You are right. Well, this year in Trig, we're about to learn a new triangle area formula. This formula can find the area of any side angle side triangle without needing to find the height. Yes, I did say side angle side triangle. So let's sketch a side angle side triangle. What makes a triangle a side angle side triangle is the length of a side, the length of another side, and the measurements of the angle included in between the two sides. This would be a side angle side triangle. Now, even if I knew this other side, let's just say this side was 11, I actually wouldn't use that in my formula because the formula only uses a side angle side. And what is that formula? Here it is in bold. Area equals 1/2 BC sine A, or 1/2 AC sine B, or 1/2 AB sine C. In other words, the triangle formula always equals, have it highlighted again right down here. The formula always equals 1/2 times one side times the other side times the sine of the angle in between the two sides. And that's always going to work with any side angle side triangle. So the measurement of the one side times the measurement of the other times the sine of the angle in between. There's a little reminder here. I want you to recall from our previous notes, the last video you watched, that a side angle side triangle is two sides and an included angle in between them. And when you have two triangles that match that way, that's how we knew they were congruent. And that was that review lesson we did not very long ago. This formula is actually derived from the original area formula. Area equals 1/2 base times height. And if you want to see an explanation of this, our textbook really does a nice job on page 488 if you want to check that out. All right, from our new area formula. So we already did one new formula. I don't want you to lose it. So let me go back up here. Your new formula, it's really the same formula, just written 3 times. You can either take it this way, or this way, or this way. So I'm just going to say this one. 1/2 side times sine of the angle in between, or 1/2 BC sine A is the way it's worded here. We have those. That's the first formula we learned. Area for any side angle side triangle. Now from that formula, we can derive a brand new formula that is the topic of today's notes, and that is called the law of sines. Now it's in our book on page 488, but I wrote the formula here for you as well. Notice that you can write it with sine on the top or on the bottom, or like either way is fine. So let me take a look at this way on the top first of all. So here is our formula. Sine of the angle over the side across from it equals sine of the other angle over the side across from it equals sine of the third angle over the side across from that. Or I can flip these and then the formula still works. That's super cool. So I could do the side over sine of the angle across from it, is equal to the second side over the sine of the angle across from it, or it's equal to the third side over the sine of the angle across from that. Kind of interesting when you use this formula, even though it shows all 3 sides, you always use the formula as a proportion. You'll see when we get to the example part of our notes, but you're only going to use, for example, that part of the formula when you're solving. Or maybe you'll only use these 2 set equal to one another. Or if you're going to use the bottom one, because you can choose either time, kind of whichever way you write it, maybe you'll just use those 2. Or maybe you'll just use these 2. Or maybe you won't know side B and you'll just use A, sine A equals C over sine of angle C. And again, you'll see that when we get to the part in our notes, but I want you to jot all this down so you have your law of sines formula. All right, now, why do you think we're going to use this formula so much in trig? Think about it. Up to this point, we've been working a lot with right triangles. A lot. But the law of sines formula can be used whenever you have lots of angles. Let me highlight that as well. Whenever you have lots of angles, doesn't even have to be a right triangle at all, you're going to use law of sines formula. So we use law of sines for angle, angle, side, because that's a lot of angles, or angle, side, angle, because that's a lot of angles. Or we are going to also use it for the ambiguous case, which is side, side, angle, ambiguous. That's not today, and I know that doesn't have a lot of angles, but we do use law of sines for lots of angles. Here's the two cases, or side, side, angle, ambiguous. All right, I'm going to do 2 friendly reminders, and then let's jump right into our examples. Friendly reminder number 1, and we've been doing this since the beginning of the year, but it never hurts to hear it again. All right, to label a triangle, it is common to use capital letters as the name of the angles. For example, this is angle A, this is angle B, and this is angle C. The side directly across from the angle gets the same letter but lowercase. So if I'm at angle A over here, I go right across, and notice that's side A. If I am at angle B, let me go right across. Yep, this is going to be side B. And finally, if I am at angle C, let me go straight across, and that would be side C. Just important to note, doesn't have to be A, B, C. It can be whatever letter in your triangle. I don't know, let's just say we had a DIS triangle. In this DIS triangle, across from the D would be side D. Across from the I would be side I. And across from the S would be side S. All right, one more friendly reminder before we jump to examples. Friendly reminder number 2. To solve a triangle, right up here if you are following along on the screen, to solve a triangle means to find the length of all 3 sides and the measures of all 3 angles. That's how you solve a triangle. Essentially, you find everything. Length of all the sides, measure of all the angles. My question for you is, how many degrees do the 3 angles of a triangle always add up to? How many degrees are in a triangle? Hope everybody just said 180 degrees. That's going to help us as we go about and do our work here. Now we're going to switch over to a whiteboard, but I just want to show you this is what we'll be doing together. So you could always pause it on this part if you want to jot these down. We are going to work through 6 examples to really show you how this works. Once we do that on our whiteboard, you're going to notice we've not covered the ambiguous case yet in terms of how to solve. That will be coming up another day. And then your assignment is listed here as well. But let's go ahead and knock out example 1, 2, 3, 4, 5, 6, and head into your assignment. Here we go. Our first example is on page 488, and it wants us to find the area of triangle RST. So the first thing I notice when I see this triangle is that I have a side, angle, side triangle. And I'm going to need that to use my brand new area formula, which states that the area is equal to 1/2 the side times the other side times the angle included in between them. So in my case, let me get rid of my side angle, side markings. In my case, that would be 1/2 times side T times side S times the sine of angle R. All right, so let's do that. Area equals 1/2 times 6 times 4 times sine of 30 degrees. Sine of 30 degrees is actually on our unit circle, so I could do it by memory, but let's type this one in the calculator since a lot of times these won't be. First, I check to make sure I am in degree mode, which I am, and you can see that on the top of my calculator here that it says degree. Then I'm going to type in 1/2 times 6 times 4 times the sine of 30 and close my parenthesis, and there's my answer, 6. So the area of this triangle is 6 centimeters squared. Do you remember from your experience with geometry, area always comes in square units. So since my sides were in centimeters, my area is in centimeters squared. If for some reason you were ever given this formula in radians, I'm just going to ask that you convert this to degrees first. I believe the book will always give it to you in degrees, but just in case, and make sure your calculator is in degree mode. All right, let's shoot to example number 2. Example number 2, located in your book at the top of page 489, says to solve triangle ABC. Now, I know that solve means find every angle, find every side measure, and round to the nearest tenth. Now, first I got to figure out how I'm going to do this. So what type of triangle do I even have? Looks like I have an angle. Can't go this way, not crowded enough. Let me take the traffic way. Angle, angle, side. If I have an angle, angle, side triangle, that means I use law of sines. And I know that because I use law of sines when I have lots of angles. So for angle, angle, side, for angle, side, angle. And I'm also going to use law of sines if I ever have the ambiguous case, which I can't really fit in that corner. But any of these 3 cases, I know I'll use law of sines. So this is going to be a law of sines. So I know I'm going to use law of sines. Before I do that, I can just figure out angle C because I know there's 180 degrees in a triangle. So I've already used 38 and 65. So I've already used on here 103. I have 180 to work with. If I subtract that out, I know angle C is 77. So I'm just going to go ahead and label angle C 77. Now, whenever I do a law of sines problem, I always have to figure out, first of all, what's my main pair? Now, my main pair, in which I know both the angle and the side, is right here. It's A. I know angle A, and I know side A. So this is definitely going to be in my ratio. I don't know side B. I don't know side C. So I'm going to have to do this twice. Let me go ahead and find B first because it comes first alphabetically. So let me use the pair I know. Now remember, here's my formula. Sine of A over A is equal to, since I decided to do B first, I'll do sine of B over B. All right, let's fill in the info. Sine of angle A means sine of 38 degrees over, how big is side A? 16. Equals sine of, do we know angle B? Yep, 65 over side B. Now, my job is to solve for B here. Since there's an equal sign and 2 fractions, makes the most sense to cross multiply. So let's multiply these and set them equal to those. So B times sine of 38 degrees is equal to 16 times the sine of 65 degrees. I'd really like to get B alone, so I don't like that this says times sine 38. So let me divide off my sine 38 here. All right, B equals, whatever that equals. I better be really careful when I type this in my calculator to use parentheses so they know what I'm talking about here. So let's take a look at how we're going to type this in. We want to type in 16 times the sine of 65. Have to close that parenthesis since it prompted me with one. Divided by the sine of 38, close that parenthesis. And it looks like my answer is 23.55340585 to be continued. Let's round that to the nearest tenth. So 23.6 because that 0.55 is going to round up. So B is 23.6 approximately. All right, so let's fill that in on our picture. B is 23.6. And now let's go ahead and find side C. Now I'm going to erase this to give myself some room. When I go to find side C, I'm still going to use my favorite pair. A is my favorite pair in this problem. So I'm going to use my sine A over A again. But this time, I'm going to set it equal to sine C over C. Let's fill in all our info. Sine angle A was 38 degrees over side A was 16. Equals sine, how big is angle C? 77 over side C, which is my unknown. Again, I'm trying to solve. I have an equal sign and 2 fractions. Makes the most sense to cross multiply here. So I'm going to multiply these and set them equal to these multiplied. So that's C times sine 38 equals 16 times sine 77. I wish the C was alone. I want to get rid of times that. Let's divide that off. Sine 38. Notice the sine is connected to the 38. You can never just divide by the sine or by the 38. They come as a package. Divided by sine 38, divide that off. C equals whatever that is. Not sure what that is. Let's try it. Let's type in 16 sine 77, close that parenthesis, divide it by the sine of 38, close that parenthesis. C is about 25.3 when we round it to the nearest tenth, 25.3. I'm going to put that in my triangle. Then I'm going to do a quick visual logic test to see if this makes sense. My smallest angle is across from my shortest side. Good. My medium angle is across from my medium side, and my large angle is across from my large side. I feel good about this example. It all worked out. All right, that was example 2. We have a couple more to go, so I'm going to go ahead and pause the video here. Example 3, scene 1, we had written up on the whiteboard. If angle A is 75 degrees, angle B is 30 degrees, angle C equals 5, no, side C equals 5. Find the length of side B. All right, first of all, I don't even know what formula I'm going to use. I definitely need a picture here so I can try and figure things out. So I'll just quick draw an ABC triangle, not drawn to scale. Put in 75 for A, 30 for B, side C is 5. Not that I necessarily would need to, but why don't we go ahead and find angle C, just because we know triangles add to 180. So we know that we already used 75 and 30. We already used 105 degrees, but a triangle has 180. So 180 minus that 105 will give us 75. So I know that side C is 75. Very interesting. It looks like I actually did need to find side C. You might also be able to tell me how big this side is just from your information in geometry. If you remember that isosceles triangles, so if these are both the same, that means these are both the same. I actually know this is 5 as well. But even if you didn't notice that, you don't have to. Let's say you don't know this is 5, and you don't notice this is an isosceles triangle. Let's just focus on what we need to find. We need to find side B. All right, and here's what we were originally given. I was originally given an angle, side, angle, triangle. And remember, whenever I have lots of angles, I use law of sines. So I can use law of sines here. So let's go ahead and do it. Now I need to find a partner somewhere where I know the side and the angle, which means I did have to find angle C, because now here is my favorite pair. I know angle C and I know side C. So let's start our law of sines ratio using C. So let's do sine of C over C equals, we're finding B, so sine of B over B. I'm not even going to mess with the A's at all right now. Fill in what we know, sine of angle C, that's sine of 75 degrees, over side C, which is 5, equals sine of angle B is 30 degrees, over, we don't know what side B is. Looks like we're in another cross multiply situation because I have an equal sign in two fractions. Multiply these, set them equal to those. That would be B times the sine of 75 equals 5 times the sine of 30. I want this B alone. How do I get rid of times sine 75? Divide by sine 75. Divide by sine 75. That's a lot to type in my calculator, but once I do, I will have this answer. Let me put it right down here so you can see it with me. Let's go ahead and type in 5 times the sine of 30 degrees. I better close that parenthesis since it prompted me with the front. Divided by the sine of 75. Close that parenthesis. And I get approximately, let's go 2.6, I would say, round to the nearest tenth. So B is about 2.6. Now, I didn't have to solve the whole triangle here, but I do want to do just a quick logic check. I have smallest angle across from a small side, bigger angle across from a bigger side. So I feel good about it. I even happen to know this is 5 because the whole isosceles triangle thing, but I don't need to find it because it just said find side B. All right, if you're feeling pretty good about this, that is awesome. I am going to ask that you click on my second video link to see our final 3 examples, and then you'll be able to continue on with your classwork. So I will see you at that next link. See you soon.